Imagine a world where robotic insects take over the critical task of pollination, freeing farmers from relying on the whims of nature or resorting to manually pollinating crops with paintbrushes. These high-tech marvels, inspired by nature's own pollinators, promise to revolutionize agriculture by boosting efficiency and reducing environmental impact. Scientists at MIT are diligently working to reinvent artificial pollination, which will bring us closer to this sensational reality. Small pioneers of giant transformations. These tiny mechanical marvels that are smaller than the size of a paperclip are expected to expedite pollination, thereby boosting crop yields while minimizing traditional agriculture's harmful effects on the environment. Inspired by bees, these robotic insects could soon swarm out of mechanical hives to perform precise pollination, mimicking the efficiency and agility of their natural counterparts. The inception of robotic insects. MIT researchers drew inspiration from bees to design these miniature robots. Kevin Chen, an associate professor in the Department of Electrical Engineering and Computer Science, head of the Soft and Micro Robotics Laboratory within the Research Laboratory of Electronics, and the senior author of an open access paper on the new design, leads this innovative project. Chen and his team recognized that earlier versions of robotic insects lacked the endurance, speed, and maneuverability of natural pollinators. This led them to redesign the robots, mimicking the anatomy and flight mechanics of bees to achieve greater efficiency and precision. The research team, including co-lead authors and graduate students, collaborated to produce their findings, which were published in Science Robotics. The evolution of robotic insects. The latest robotic insects represent a significant leap in design. The revamped bots can hover for about 1,000 seconds, over 100 times longer than their predecessors. Weighing less than a paperclip, these robots achieve remarkable speeds, perform acrobatic stunts like double flips, and track trajectories as intricate as spelling MIT. The design improvements include more sophisticated transmissions that connect the wings to soft actuators, or artificial muscles, which minimize mechanical strain while increasing precision and agility. Each unit now features a single wing pointing outward, which reduces interference between wings and creates space for future enhancements such as tiny batteries or sensors. Overcoming challenges. Initial designs with 4 units and 8 wings faced issues where the wings interfered with each other's lift forces, but there is no insect that has 8 wings. In our old design, the performance of each individual unit was always better than the assembled robot, Chen remarked. The team halved the number of wings and reconfigured their alignment, significantly improving flight performance. Fabricating the wing hinges was another challenge. These 2 centimeter long, 200 micron wide components required a multi-step laser cutting process to ensure precision. If you have even a tiny alignment issue during the fabrication process, the wing hinge will be slanted instead of rectangular, which affects the wing kinematics, Chen explained. The promise of progress. The latest design breakthroughs bring the team closer to practical applications like assisted pollination. The amount of flight we demonstrated in this paper is probably longer than the entire amount of flight our field has been able to accumulate with these robotic insects, Chen shared. Future goals include achieving flight durations in excess of 10,000 seconds and enhancing the robot's precision to land and take off from flower centers. In the long term, the team envisions equipping the robots with sensors, batteries, and computing capabilities for autonomous navigation outside the lab. A glimpse into the future. As Kevin Chen and his team continue to push the boundaries of robotic insect design, the promise of swarming battery-powered pollinators edges closer to reality. With each iteration, these miniature marvels become more efficient, agile, and precise, bringing them one step closer to deployment in real-world environments. They could bring revolutionary change in modern agriculture by making it possible to produce fruits and vegetables within controlled environments such as multi-level warehouses with robotic insects to remove the shackles of seasonality, climatic variability, and the decline of natural pollinators on crop production. It is envisioned that such a shift would bring a surge in crop yield while opening doors to a greener, more responsible means of farm operation through pesticide-free and non-water hogging systems. A whole vision of an army of robot pollinators marching across farms symbolizes technology with the science of biomimicry, redefining everything related to the food sector. These robots may one day help solve some of the world's most pressing problems in food security and environmental conservation.